Tutorial 6. Simple Math in Max Performing Calculations. This tutorial covers the basic mathematical operations that are available with Max objects, and the process of connecting up several objects into a calculation chain. We will also cover the common operations of objects with multiple inlets, and some issues with numeric conversion. Common math operations, such as addition and multiplication, are important for manipulating incoming data into a range and form that is useful for our patches. Additionally, dealing with the difference between integer and floating point numbers is critical when working with many types of data such as MIDI, audio, and serial information. Everybody loves math. Look at the tutorial file 06msimplemath.maxpat. The top row of patches shows examples of the various simple mathematical operations that are available in Max. The leftmost patch performs addition using the plus object. The plus object, like most math objects in Max, has two inlets, one for each operand. Numbers coming into the right inlet are stored and added to numbers coming into the left inlet. If no number has yet come into the right inlet, the right operand is set to the object's argument. If no argument is supplied, the right operand defaults to 0. When we click on the message box containing the number 2, the result is revealed to be 2 as well. Since no number has come into the right inlet, the current stored operand remains 0. Clicking on the message box with the number 3 produces no output, but stores the number 3 as the new right-hand operand. When we click on the 2 again, we see the additive result 5 displayed in the number box. The next patch uses an argument to the plus object that sets an initial default value for the right-hand operand. Now, when we put a number into the plus object, we see a result without having to send any number into the right inlet. Using default arguments for math operations is a common setup in many situations where you need to perform a constant mathematical operation on a stream of input values. Next are the in objects, which perform subtraction and multiplication, respectively. Like the plus object, they have default operands of 0, and accept stored values in their right inlet, and produce results based on values coming in the left inlet. The divide and modulo operations are also similar, but with one difference in order to prevent unwanted divide by 0 errors. Their default right-hand operands are 1 rather than 0. Inlets, hot and cold. As we've seen in the first set of math objects, some inlets cause an object to output a message, while others cause the object to simply store values. In fact, messages sent to any of the inlets cause these objects to store values. The difference is that values coming in the leftmost inlet have an implicit bang message attached to them. This forces the math object to output the result of the calculation once the value is received and stored. We can see this in action by attaching a bang object to a math object, and using it to explicitly force output. The first patch in the second row is a simple addition patch, but with a button connected to the left inlet. Sending numbers into the plus object performs the expected result. Numbers in the right inlet are stored and used as a right-hand operand, while numbers in the left inlet are used as left-hand operands and cause the object to output results. Clicking on the button also produces a result. The addition is performed with the current set of operands, and the result is sent out of the outlet. This is useful when you want to change the right-hand operand, but want output without having to resend the left-hand operand. It is also a good example of the bang message performing its do it function. Inlets that cause an object to output messages are often called hot inlets, while inlets that only store information are called cold inlets. It is a common practice, when a cold inlet needs to produce output, to apply a bang message into the leftmost inlet to force output. Type conversions through arguments. The next two parts of the patcher show what appear to be equivalent operations using the plus object. Both of them purport to add together the numbers 2.5 and 12.75. Try them both out. The result of adding 12.75 and 2.5 should be 15.25. But between the two plus objects, only the right-hand one produces the correct result. The left-hand plus outputs 14. Why? Like many programming languages, Max has different types of numeric data, and operations on that data can be done using integer or floating point mathematics. By default, all of the objects that perform math operations in Max use integer-based arithmetic. When floating point numbers are received by a math object in integer mode, they are truncated to integers before being used. Thus, 12.75 becomes 12, and 2.5 is converted to 2, which adds up to 14. In order to set a math object to use to floating point arithmetic, we need to provide an argument that is floating point. The right-hand patch does just that, it uses a 0 argument to inform the plus object that we want to perform floating point arithmetic, and the addition results in the 15.25 value that we were expecting. Forcing a calculation, the final two patches in the second row show a simple mechanism for triggering output from the plus object, regardless of which inlet receives messages. The left inlet is fed directly by a number box. Since left inlets are already hot, they need no further attention. However, in order for the right inlet to produce output, we have to send a bang into the left inlet after the right inlet has received input. This is a perfect application for the trigger object, which is used to manage this function. In both cases, the trigger object has two outlets. The right outlet is type-specific, while the left sends out a bang. When a number is entered into the object, trigger processes the arguments in a right-to-left order, first sending the numeric value into the right inlet of the plus object. Then, a bang is sent to the left inlet of plus, forcing calculation and output to the number box below. In this way, we can force both inlets of the plus object to behave as though they are hot, and receive output regardless of which inlet is sent messages. Using cold inlets for recursion at the bottom of the tutorial file is a curious little patch that has the result of a plus object feeding back into itself. You can see what is happening by clicking on the top number box, entering a number, and then entering more numbers after that. As you enter numbers, the result keeps accumulating. This is a case where we are taking advantage of the cold inlet of the plus to change its right operand based on the previous operation's output. In this case, the result of the addition is fed back into the right-hand inlet, where it is stored as the right operand for the next addition operation. This results in an accumulation of the output, which can be handy for tracking a running total of incoming values. These types of recursive operations are useful for making counters, smoothing algorithms, and pieces of code where the system's behavior is dependent on previous outputs of the system. Cascading math objects. All of the above examples have been pretty simple. They've been simple math operations with a simple result. However, you can chain several of these operations together to create a more complex equation. For example, let's say we wanted to make a max patcher for converting temperatures, specifically, converting Fahrenheit to Celsius. The formula for this conversion is degree C equals. From an object standpoint, it might be easier to simplify this to degree C equals 5, 9. We can produce this output by using the dash and objects chained together. Unlock the patch and begin by using a number box for the Fahrenheit input. Connect this to a object with an argument of 32 as the default right-hand operand. Connect the output of the object to an object with 5 as an argument, and connect it to an object with 9 as the argument. Finally, connect the output of the object to float number box to see the result of the Fahrenheit to Celsius conversion. Summary: the mathematical objects, used either singly or in a sequence, provide the tools necessary for manipulating numeric input in many ways. The math objects provide both hot and cold inlets, but simple patching operations can be used to force output on cold inlets. Math objects, by default, perform their computations using integer arithmetic. An argument with a decimal point can be provided to tell the object to perform arithmetic using floating point numbers.